Well, write the structures of the major organic product in each of the following reactions. Wow, let's take a look. You have CH3, CH2, CH2Cl, NaI in acetone, Finkelstein's reaction. Halide exchange reaction, you get CH3, CH2, CH2I, and NaCl precipitates out. Finkelstein's reaction, classic SN2 reaction. We have tertiary butyl bromide with KOH, ethanol and heat. Wow. Now, alcoholic KOH, popular elimination stuff, and tertiary butyl bromide is a classic recipe for elimination. What happens is this. Just watch. If you have OH minus attacking, it goes off, and yes, it can always push away Br, and what you get is CH2, a very classic dehydrohalogenation reaction. This is what is called as E2 elimination mechanism. Halogen and hydrogen. This is, as you can see, alpha carbon, beta carbon. All these three are beta, they are same, identical. You remove H plus from anywhere, you get alkene like this. So isobutylene is the major product in this case, and although it has not been asked, but the mechanism would be E2 in case you find it relevant. Well, we have CH3, CH, CH2, CH3. We have 2-bromobutane. And you have aqueous NaOH. Now, aqueous OH minus, this is, that mostly promotes SN2 substitution, and at least with secondary alkyl halides. So, if you use OH minus, you have predominant SN2 attack, and Br gets substituted by OH. As simple as that. CH3, CH2Br with aqueous ethanol and potassium cyanide. Cyanide is a classic nucleophile. Attack. Beautiful and fast and quick and rapid SN2 reaction, and you get CH3, CH2, Cn. This is the reaction which is going to happen easily, happily, and quickly. C6H5ONa plus ethyl chloride. Now, if you just see, in this case, you have a strange nucleophile, the huge and bulky phenoxide ion, and you have CH3, CH2, Cl. How do they react? Can you draw the arrows and show me the reaction? That's not difficult. Attack, crack. Whichever carbon to which halogen has been attached is the alpha carbon, and that is the site of reaction. What happens? What do I get? It seems I am in for an ether. Yes. I get ETOPH plus, of course, Cl minus goes away. You have NaCl. You can use it for cooking food, making whatever. Yeah, there we are. You have propanol and SOCl2, the very famous thionyl chloride. This is Darson's reaction. What do I get? SOCl2 replaces OH by Cl. It is a halogenation reaction. I get CH3, CH2, CH2, and the change happens here. I get Cl and SO2 and HCl. The most beautiful part of this conversion is that all the other products are gaseous. SOCl2 is a gas, SO2 and HCl are gas. If you use excess of SOCl2, all the alcohol reacts away, so it is the limiting reagent, it gets exhausted. So the product can be pure propyl chloride, and this purity of product is so valuable that it makes Darson's reaction a very favorite reaction. We have 1-butene with HBr in presence of peroxide. And this is crash effect or anti-Markovnikov addition. What do I get? I get H and Br added like this, anti-Markovnikov, 1-bromobutane. That is the answer, and the mechanism goes by radical mechanism. Well, let's take a look. CH3, CH, double bond C, CH3, CH3. like this. This is what I have, and I am trying to add HBr. First of all, if you add H plus, what happens in electrophilic addition? Well, you find the more stable carbocation is formed. If H gets added here, I get a tertiary cation which is more stable indeed, and this is very much in accordance with Markovnikov's rule also. Hydrogen will go to that carbon which has more hydrogens. This already has one hydrogen, this has no hydrogen. And then Br minus gets added. So I get ting, tang, ting. This is the major product. Yes, that is the answer.